There we go. All right. Well, unfortunately, she just left. However, here's the issue. Look at your x-axis. It's only going from -10 to what? 10. Well, wasn't our height much bigger than 10? Yeah. Candies grabbed. It's only going from 1 to 7. Didn't we have more than 7 for most of us? So here's what we need to do. Go back to menu.
Oh, you can just delete the number.
Nope, don't do that. Okay. Go to menu. We need to change the window we're looking at. So what are we going to go to? Window/zoom. Okay. And you can manually change the window, but look at all the options. Does anyone see an option that might help us find our data really well? Zoom data, right? You can do zoom out, but there's an option that says zoom data. Oh, there's our data. It just does it for you.
What? So
did it disappear? Go back to menu, go to zoom, data. Oh, that's the wrong one. Yeah. It's easier to just hit the number, right? So just hit 9. You didn't enter the data accidentally somehow.
Which graph do I go to? This one.
Yeah. See how it doesn't have anything under the scatter plot?
And what graph did you start on?
So what you need to do is hit height, then hit tab, go to the next one, and then go to candies grabbed. Hit enter, enter. Now we can do it. Okay. So go to zoom data. All right.
Still can't do it. It's still not working. What thing do we start on? Do you want to start on a new one or one of the old ones?
Well, it doesn't matter. You just need a graphs page.
So it's like that.
That's not a graphs page. There you go. Nope. You got to enter the scatter plot first. There we go. So put your variables in there. Okay, at this point, it's not perfect. In fact, we have one data point that's way down here. But does it seem like there might be some relationship between the height and the number of candies grabbed? Notice when you're shorter, we have fewer numbers of candies grabbed. We see all that? We go with that. And when you were taller, were there more candies grabbed in general? Is it a perfect relationship? No, but there is some correlation there, okay? So, here's a question for you, and this is important. Actually, let me check something. I'm going to go to View. I want a line grid so you can see it a little bit more clearly. Let's just go by. Okay, this is cleaning things up. I'll show you more about this later. But the reason why I want to point this out is this right here is 61, 62, 63, 64, 65, 66, 67, so on and so forth. If someone is 69 inches tall, right? So 61, 2, 3, 4, 5, 6, 7, 8, 9. They're 69 inches tall. How many candies do we expect them to grab? Notice there is no one who was 69 inches tall. How many candies would I expect them to grab?
0.
Just follow that line right there.
Follow that line right there?
Like dot, dot, and I'll put a dot right there.
So like, you think this line?
No,
Why not?
because that's not what
That's not
That's
69.
not.
That's not going to help me get it for 69?
Those dot lines, the dots.
So like, could I go like right here?
Follow
That's not what
where
I'm gonna do.
That's not what you're going to do?
the
Can you come up here and show me what you would have done?
the line is.
We're going to talk about that in just a second. Okay? So where do you think we should follow the line from? Okay?
And then you'd go to 69 and it'd be wherever.
Okay. Does anyone have a different line that they might put in here? Close, but a little bit different? Nobody?
Is that a circle?
Where
Oh, that's the.
where I might put my line is I might start here and go through here. Why do you think I might do that?
That's in the middle.
Say it again.
In the middle.
It's kind of in the middle, right? And I'm not saying that Gracie's was bad. She had much better than my original two. But notice how there's lots of different lines that could show the relationship here. And you said an important word, Jada. What was it? Say it louder. A line of best fit. Okay? We're going to get to what the actual line of best fit is. It's called a least squares regression line, but we're not there yet. In general, these lines that we have shown so far, and I would make this note there because it definitely should go on number, actually we need to go over some of these in just a second. Under the last one, right, where it says what mathematical concept shows the relationship between explanatory and response variables? That'd be this thing.
Line of best fit.
We want a line of best fit. For now, we just have something called a trend line. It's showing a general trend. That's it. So go ahead.
Right trend line on the last one.
Yeah, to start with that question, the thing that is showing that relationship between explanatory and response variables, that is a trend line. Okay? Do you think that this trend line is better than the average that we studied earlier?
Yeah, sure.
I mean, does it seem closer or more accurate to those data points in general? Because remember, there was a lot of standard deviation, a lot of variability when we just looked at the average and all around it, right? But there's a relationship between height and number of candies grabbed, so we want to recognize that. But what do y'all think about Gracie's strategy earlier of, okay, so here's 69, I'm going to come up, and that's how many I would expect?
That's what I would do.
That's what you would have done? So 60, no, those 4, 8, 12, 16, 20, so maybe 19 candies grabbed is what we'd expect for something that tall. And so this is known as interpolating, all right? If you don't know that word, it's okay. It's part of the objectives, though. So when we interpolate, we are using and this should go somewhere within that last part there, but interpolate, that is when we use a trend line to predict within the data set. Okay, 69 inches, that's within the data set, but we didn't have something there, and it's still a prediction. Say again. Okay, so interpolate, use a trend line to predict within the data set. Anyone want to guess or have an idea what it's called when we use a trend line to predict outside of the data set? Extrapolate. That's it. We extrapolate when we use a trend line to predict outside the data set. Okay? So that's when we use the trend line to predict outside the data set. And what I want you to notice and I want you to think about is there is a relationship between height and candies grabbed. So when we use a trend line based on that, it's going to give us a better prediction for how many candies a person grabs than just using a pure average. Because does anyone remember what the pure average number of candies grabbed was? 14.9 candies, right? But if we have someone who's 69 inches tall, we're expecting them to grab how many? 19. It predicts, the height is predicting how many candies they can grab. it is going to give us a more accurate representation. Does that make sense? Okay, do we need to talk about maybe some of the questions to make sure we've addressed them all? Say that one more time. We talked about number 2, what mathematical concept predicted the number of starbursts we expect the next person to grab? Remember, that's when we talked about the mean, right? So the mean number of starbursts was just, hey, if any random person comes up and grabs, how many would we expect them to grab? The mean, right? But did we believe that prediction to be accurate? Nope. Okay? So what mathematical concept predicts? That is the mean, which was 14.9 candies. But, does anyone remember what we addressed to realize, hey, that's not super accurate? There's a standard deviation. Which that really just means there's a lot of variability. So did we believe it was very accurate? Right? There was a high standard deviation, a lot of variability, so it's not very accurate. We're about to talk about it, make sure we address it. Everyone have everything with 2? Okay. So here's 3. So what are some potential explanatory variables? And yes, we did address this. What potential explanatory variables did we talk about?
Hand size.
Hand size.
Gender. Height.
And height. What else? Foot size. What else?
Container.
Container. Anything else?
Gender.
Gender. I feel like there's a couple more we talked about.
The basketball.
Okay, so dribbles in a minute. Say again. Oh, time to school, yes.
There was one more you said, but I don't remember it.
Oh, it doesn't matter. It was one that, I think it was screen time, daily screen time. There might be a relationship there, I don't know. And so then what mathematical concept showed the relationship between explanatory and response variables, right? That was the trend line. Why can this be better? Well, because there's a prediction, right? There was less variability around that trend line, right? And then we talked about how to predict values, right? We're going to do a quick exit slip on the calculators in a second, but I do want to show you one last detail before we wrap this up, just so you can see it again, okay? Notice what we had here was, we had a single variable, the candies grabbed. We had that the average was right here. Do you see how spread out those points are from there? And there's even these are like very far separated from the rest, right? But look again at this scatter plot with a trend line going through it. It's not perfect, but does it look like the data points might in general be closer or further away from that trend line than from the mean? They're closer, right? A trend line, and this is a detail I do want you to write down under number 4, a trend line is going to reduce variability because of the explanatory variable. There is something that explains the response variable. Okay? The trend line reduces variability because there is something that explains the response variable. Should I say that one more time? The trend line reduces variability because there is something that predicts the response variable. I just sent you a file. It's got a few questions on there. Once you finish writing that down, I want you to answer those questions.
something that predicts what?
A trend line reduces variability because there is an explanatory variable that predicts the response variable. Okay, the trend line reduces variability because the explanatory variable predicts the response variable. Okay. As I said, I already sent a file out to the calculators, read through the questions, answer the 3 questions. Hopefully, we should be able to answer these questions pretty well by now, so this is a quick little check to make sure we know how to answer them. And if not, there's some stuff I'll have to address on Monday.
What the heck?
This is so stupid.
What's wrong? If there's technological issues, let me know. I'll come and look at it.
I can't write anything.
Hey, really quickly, just so you know, I'm just trying to see if you know how to do this and what things I need to go back over, so just try to do this individually. If you can't do it, I need to know that.
On 1.1, we supposed to do scatterplot.
Um,
We supposed to do a scatterplot.
yeah, number 1, I've already put the variables in, you just need to make the scatter plot, right? You read through the directions, I know there's a lot, data has already been entered with the weight of the individual in kilograms as the independent variable, and candies grabbed as the dependent variable. Create a scatter plot on this page and make sure that the data is clearly visible in the window. Alright? So the variables are labeled as weight and candies.
Somebody
Oh, I skipped that.
Okay?
'Cause I don't know it.
So and then please notice there's 2 more things after that first one. Hey Jada, there's 2 more questions.